University of Wrocław offers Master Studies Applied Geoscience. Faculty of Earth Science and Environmental Management. Welcome to Institute of Geological Sciences. Have you ever wondered about becoming an outstanding specialist familiar with social, environmental and economic issues of the developing world? It is a perfect moment to apply for a master program Applied Geoscience. The diverse program of the specialty Applied Geoscience and the wide range of its components give a student a comprehensive applied education covering knowledge on mineralogy and petrology, stratigraphy, structural and economic geology.
We are in the laboratory of economic geology where we study mineral deposits. We focus here on two types of deposits, either metallic ones or fossil fuels. We use different techniques to study these rocks. One of them, for example, is the microscope that we use to study inclusions. Now, this microscope, we can study either fluid or gas inclusions. Now, those gas inclusions or fluid inclusions, they are tiny, about a micrometer size inclusions that were trapped when the mineral was growing. With the use of this microscope, we can heat the sample and we can look at the changes of the different phases that are trapped within the inclusions. Based on the research, we can tell about the temperatures and pressures that were existing when the fluid inclusions were formed. It's important because studying those inclusions, we can obtain information how the mineral deposits were formed.
Environmental geochemistry and environmental protection.
In my classes, we use mineralogical and geochemical methods known from the earth science. However, we go beyond classical geoscience approach and we are studying industrial waste. An example of waste that we study is this sample of smelting slag. This material is analog of naturally occurring volcanic rock. That's why, as geoscientists, we are perfectly able to characterize this material in terms of mineral phase and chemical composition. Based on knowledge acquired during classes, students are able to indicate whether this material could be used to replace naturally occurring rocks, for example, for production of aggregate. Students find out also whether this material could constitute potential environmental risk or whether it could be safely stored on the waste dumps.
Applied hydrogeology.
Hydrogeology is one of the most important sections in geoscience because it considers the water resources, groundwater resources. So we, as a hydrogeologist, we try to calculate the flow of groundwater in the environment and how to protect the quality and quantity of groundwater resources in a catchment, in a hydrogeological structure, in major groundwater basins, etc. We have several different techniques that we usually use to evaluate groundwater resources, and one of the most advanced technique nowadays is groundwater modeling. Mining problems, how to predict mining, the watering system, pumping. We try to develop the geological structure of the system. We can adopt such a model to calculate the velocity of pollutant migration.
Institute of Geological Sciences offers well-equipped laboratories.
In our institute we have several well-equipped labs used for teaching and for preparation of master dissertations, and right now we are in one of them, and it's used for teaching of basic chemistry courses for geologists and also for more advanced courses in geochemistry and environmental geochemistry. It's also a perfect place to prepare a master dissertation. If someone does simple chemical experiments, it can be done here.
Institute of Geological Sciences offers advanced equipment.
An important part of research and teaching in the Institute of Geological Sciences and also in the Department of Mineralogy and Petrology is the study of rocks and minerals. And we have several pieces of good scientific equipment to do that. One of these devices is the scanning electron microscope. You can put rock specimen or microscope specimen into the machine, and then using magnification of several hundred times or several thousand times, you can observe the texture of this specimen. It means the spatial relationships between minerals. It's possible to measure the chemical composition of mineral phases present, and finally to identify the components based on their chemical composition. Another piece of equipment is the Raman spectroscope. Specimen is loaded here, again a piece of rock or a mineral, and then a laser beam is applied to the specimen, and this light, laser light, is scattered in a specific way, which is characteristic to each chemical substance, to each mineral. And using specialized software, we can analyze the scattered spectrum and identify the mineral phases present in specimen. Another research tool that we have in our labs is the X-ray diffractometer. This equipment applies X-ray beam which falls onto the specimen and is diffracted in a specific way. It is recorded and sent to computer, and in the computer we can see the diffraction pattern of the substance being investigated. We can identify minerals present in the specimen. So altogether, we can use this equipment both in research and also in applications. And we teach our students how to use the equipment and how to interpret the data.
Our research covers various problems in earth and environmental sciences.
We analyze natural rocks as well as artificial man-made materials like mortars, concrete, ceramic, modern and historical. Optical microscopy serves as the basic analytical tool in the characterization of aforementioned materials. As an example, we can analyze sandstones. Petrographic microscope allows us to detect the mineralogy of skeleton as well as matrix and cement. For more precise analysis, we use scanning electron microscopy, thermal analysis, X-ray diffraction and others. During our classes, students will get familiar with the aforementioned set of analytical methods.
Our research remains at the forefront of many disciplines: geochemistry, mineralogy and petrology, soil science, hydrogeology, and microbiology.
We carry out experimental simulations illustrating interactions of bacteria with variety of solid materials, including wastes, rocks and minerals. The knowledge we get is crucial to assess environmental impact, to develop remediation strategies, as well as to improve metal extraction technologies.
The acquired geological knowledge allows students to find an employment primarily in a variety of geological surveys, industries and services related to construction, environment, exploration and protection of its resources, as well as the search for natural resources. We look for candidates from all over the world. Recruitment procedure. Become an outstanding expert in earth and environmental sciences. Choose Master Studies Applied Geoscience.